tonight, the solar system holds its breath. A mysterious object, known only as 3I Atlas, is about to brush past Mars, closer than any interstellar traveler we've ever caught in detail. At just 0.19 astronomical units from the red planet, every Mars orbiter is rushing to lock eyes on it, desperate not to miss a single clue. But this isn't just another comet drifting through space. Its blazing emerald glow, its unexplained microaccelerations, and its chemistry overflowing with carbon dioxide have already broken every rule in the cosmic playbook. Earth's instruments are about to go blind, leaving only a handful of spacecraft orbiting Mars between us and the truth. Is 3I Atlas just a bizarre outlier of nature, or could it be something engineered, something that forces us to rethink what alien really means? The countdown is already running, and in just a few hours, the data that comes back could change everything we thought we knew about visitors from beyond the stars. For 6 critical hours, Earth goes blind. It's not a failure of planning, and it's not a technical glitch. It's geometry. As 3I Atlas hurtles past Mars, Earth's line of sight is swallowed by the sun. And in that instant, Mars becomes the only vantage point in the entire solar system. Every major asset in orbit, the MAVEN spacecraft, Mars Express, and the ExoMars Trace Gas Orbiter, swings into action. Each one has been drilled, prepped, and loaded with backup configurations. Their teams know the rules. No mistakes, no single points of failure. Inside the MAVEN Control Center, the so-called Red Watch crew takes charge. These are the operators trained for contingency, the people who rehearse decision ladders for every possible anomaly. In the hours before the blackout, they run rapid drills, switching between standard science modes and burst mode spectroscopy, ready to pivot at the first sign of trouble. Every command is logged, every data packet copied twice. There's no room for improvisation, and yet, everything depends on improvisation. The schedule is merciless. Mars Express snaps broadband images every few minutes, stacking exposures to catch even the faintest signs of fragmentation. The Trace Gas Orbiter sweeps the comet's coma with spectrometers, searching for spectral lines that don't belong. MAVEN sensors monitor charged particles and ripples in Mars's atmosphere, hunting for anything that hints at an unnatural interaction. Even the rovers on the surface, Perseverance and Zhurong, stand by, listening for indirect fallout. A dust change, a glow on the horizon, anything unusual. For these 6 hours, the fate of discovery hangs on a razor's edge. If a burst of debris erupts, if a single anomaly slips by, the world may never know. And as the countdown ticks forward, the pressure only builds. But then, something strange begins to happen. Signals that defy every rule in the Cometary Handbook start whispering across the data streams. The first warning didn't come from NASA, or ESA, or any professional observatory. It came from a backyard telescope in Pune, India. Citizen astronomer Priya Ryalo noticed something bizarre, a repeating pulse in the light curve of 3I Atlas. The object wasn't just brightening at random like normal comets do. It was flashing with rhythm, switching on and off as if controlled by some unseen hand. At first, many dismissed it, but then larger telescopes joined in, and the oddities only grew stronger. The brightness pulses weren't chaotic bursts of outgassing. They came with clockwork precision, separated by nearly identical gaps. Each spike rose fast, then decayed smoothly. Nothing like the jittery, unpredictable flares seen in ordinary comets. Even as 3I Atlas drew closer to the sun, the rhythm held steady, unblurred by distance or glare. Spectroscopy revealed an even bigger shock. Instead of water vapor dominating the spectrum, as it does with virtually every known comet, this object was overflowing with carbon dioxide. The CO2 to water ratio wasn't just high, it was off the charts, 8:1, an order of magnitude higher than any comet on record. Lab models could barely simulate it, and yet, there it was, an icy traveler glowing green in the Martian sky. That emerald coma wasn't just a trick of light. At 516 nanometers, the green glow peaked with an intensity no ordinary chemistry could explain. The usual suspects, C2 swan bands, carbon monoxide emissions, didn't come close. And then came another twist: nickel emission lines, brighter than iron by a factor of 4. In every other comet, iron rules. But in 3I Atlas, the rules had flipped upside down. Imaging only deepened the riddle. The coma's light came with a negative polarization branch, more typical of asteroids than icy wanderers. Its dust grains weren't flying out in chaotic jets. They were large, slow, and oddly deliberate, drifting in broad arcs, as though released in measured bursts. And strangest of all, astrometric tracking revealed tiny microaccelerations, course corrections that lined up perfectly with each pulse of light. No single anomaly could stand on its own. But together, they painted a picture of something that simply refused to fit into the known categories. Every dataset, photometry, spectroscopy, astrometry, fed into a dossier of mysteries that planetary scientists could no longer ignore. The question was no longer if 3I Atlas was strange. It was how far the strangeness went, and whether any natural explanation could possibly tie it all together. Scientists raced to explain the mounting anomalies, and 4 main theories quickly took shape. Each was grounded in physics, chemistry, and precedent. But none could fully capture the bizarre reality of 3I Atlas. The first theory pointed to chemistry born in the deepest cold. In this view, 3I Atlas formed far from any star, in regions where even water freezes out, leaving carbon dioxide and rarer ices to dominate. This could explain why its spectrum was overflowing with CO2, while water seemed strangely absent. Comets from our own Oort cloud sometimes hint at such chemistry, but not at this scale. No comet in the catalog had ever shown a carbon dioxide to water ratio as extreme as 8:1. Still, defenders of this model argued, the galaxy is vast, and maybe we're simply looking at a rare outlier. The second theory turned to structure. Some believed the object was riddled with volatile pockets, deep reservoirs of gas, sealed away for billions of years. As sunlight seeped through, those hidden layers could erupt, releasing jets in regular bursts. Stratified ice, uneven heating, and deep fractures might create the illusion of rhythm. Lab simulations had shown that such repeating events weren't impossible. Rare, yes, but not unheard of. Still, critics pointed out that the near-perfect precision of Atlas's pulses stretched the idea to its breaking point. The third theory focused on dust dynamics. The emerald coma and oversized grains could be the result of an unusual dust composition, shaped by magnetic and solar forces in unexpected ways. Heavy grains could lag behind, drifting in lazy arcs that matched what telescopes were seeing. And the strange negative polarization, more typical of asteroids than comets, might be explained if Atlas's dust was unusually carbon-rich, dense, and compact. Again, possible. But even the most optimistic models struggled to align all the data at once. And then came the fourth theory. Our models themselves were simply inadequate. With only 2 previous interstellar visitors on record, Oumuamua and Borisov, our catalog of cosmic travelers is vanishingly small. Perhaps these synchronized pulses, the microaccelerations, and the chemical oddities weren't engineered at all. Perhaps they were simply physics we hadn't yet discovered, subtle interactions between sunlight, volatile release, and tumbling motion that no simulation had captured. In this view, 3I Atlas wasn't breaking the rules. It was rewriting them. Each explanation had its defenders. But with every new observation, the puzzle grew sharper, not softer. None of the models explained everything, and the unanswered questions kept piling up. If the answers weren't buried in theory, then the truth would have to come from Mars, its orbiters, its rovers, and their unprecedented 6-hour window to decode the visitor from beyond. When Earth's view went dark, Mars became the universe's only window into 3I Atlas. 3 orbiters, MAVEN, Mars Express, and the ExoMars Trace Gas Orbiter, formed the backbone of the evidence chain. Each one armed with a different set of instruments, each one tasked with capturing a separate piece of the puzzle. MAVEN's ultraviolet spectrograph swept the sky for faint emissions, searching for traces of fragmentation and abrupt outbursts. Its particle counters and magnetometers ran at maximum cadence, watching Mars's ionosphere for ripples. A sudden spike in charged particles or a twist in the magnetic field could mean that something more than natural chemistry was at work. Mars Express focused on direct imaging. Its visual monitoring camera stacked broadband exposures to track the coma, looking for evidence of splitting or sudden shape change. Its spectrometer scanned from ultraviolet to infrared, searching for emissions that didn't belong, or for something suspiciously missing, like water vapor. And its plasma analyzer, ASPERA3, hunted for energetic ions that could betray an interaction far beyond the ordinary. ExoMars TGO, with its NOMAD and ACS spectrometers, probed deeper into the coma's gases. Every isotopic ratio, every molecular fingerprint was measured against known norms of the solar system. Its high-resolution imager locked onto Atlas's emerald coma, straining to catch fragmentation events or dust jets in progress. On the surface, even the rovers weren't idle. Perseverance and Zhurong listened for indirect signs, dust fallout, atmospheric shifts, even auroral glows that might dance across the horizon if Atlas's particles collided with Mars's skies. They were backup eyes and ears, less sensitive than orbiters, but another safeguard against missing a critical clue. The checklist was explicit. Was there a fragmentation pattern? Did the trajectory shift after a brightness flare? Were there spectral or radiation lines that defied explanation? Did isotopic ratios fall outside anything seen before? And above all, did the pulses and accelerations show evidence of engineered synchronization? No single anomaly would ever be enough. The rules were clear. Only converging evidence, confirmed across multiple instruments and perspectives, could move 3I Atlas from the realm of the unusual into the realm of the extraordinary. For 6 tense hours, the orbiters strained, their instruments pushed to the limit, their teams watching the data streams like hawks. If 3I Atlas was natural, the signatures would eventually line up. But if it wasn't, Mars might be the only planet to ever witness proof. 3I Atlas swept past Mars at 0.19 astronomical units, just 28 million kilometers away, while every eye, every instrument orbiting the red planet locked on. For over 40 hours, the spacecraft streamed back high-cadence data, images stacked by Mars Express, spectra logged by TGO, particle flows mapped by MAVEN. Even the rovers listened from the surface, and what they saw only deepened the riddle. The emerald glow blazed steady, the pulses held their rhythm, the carbon dioxide spectrum refused to yield to water vapor, and again, the micro-accelerations lined up with the bursts of light, as though some hidden link tied brightness to motion. Natural models explained much, but never everything. The chemistry could be framed as extreme cold, the pulses as trapped gases erupting in sequence, the dust as unusually heavy, carbon-rich grains. But the synchronization, the way motion and light moved in lockstep, that remained unanswered. No single theory could tie the evidence into one neat bow. Still, one outcome was certain. The encounter changed the rules. For the first time in history, interstellar data was released openly. Raw packets made public within hours of transmission. Protocols were rewritten. Redundancy became law. Citizen astronomers were no longer on the sidelines. They were built into the process. The age of secrecy around cosmic visitors was over. And yet, the central mystery endures. Was 3I Atlas simply an outlier, a natural comet from the deep void, flaunting chemistry and behavior beyond our expectations? Or was it something else? Something engineered? A messenger from a place where the rules we know no longer apply? No final answer came that night. The decision matrix never moved to extraordinary, but neither did it settle comfortably into conservative. For now, the verdict is unresolved. What is certain is this: the Mars flyby of 3-Di Atlas has already transformed how humanity prepares for the unknown. Every future visitor from the stars will be watched with sharper eyes, stricter protocols, and global transparency. And perhaps that is the real legacy. 3/I Atlas may not have revealed all its secrets, but it forced us to ask better questions. Questions that could one day change everything we know about life, intelligence, and our place in the universe.